Why do we have a geology book? Leonard, did you throw a children's party while I was in Texas? You remember how you explained to me that the Kardashians aren't real celebrities? Well, geology is the Kardashians of science.
According to this knob, geology is the worst science, and everyone who studies it is boring. Yes, I used air quotes. And even though that this could be slightly true, there's a lot more to it. I know you might think, rocks, they don't move, they don't do anything, they just sit there. So why care? Well, because they hold the secrets of the earth, and that is pretty fucking cool. Geology isn't just about staring at pebbles in the ground. It's about understanding why entire continents move, how mountains rise, where did life come from. If that hasn't piqued your interest, I don't know what will. To show you how great geological science is, we have to cover 4 very general areas. I'm going to keep the information light, so in the future I can cover certain topics in more depth. The 4 general areas are 1. Global structure, 2. Environmental geology, 3. Geological history, and finally, you guessed it, number 4, rocks. But I promise you, it's more interesting than it sounds. I don't want these videos to be too long. I know attention spans these days are very limited, so I'll just cover global tectonics and leave the others for future videos. Welcome to geology on a global scale, otherwise known as how this giant space rock we call home actually works. Today, we're tackling planetary geology, plate tectonics, earthquakes, volcanoes, all the ways the Earth likes to shake things up, literally. But first, let's zoom out and start in outer space. About 4.6 billion years ago, the solar system was just a chaotic space party, a nebula full of gas, dust, and cosmic nonsense. Gravity did its thing, squeezing everything together to form the sun, while the leftover rubbish turned into planets, moons, and a few unlucky space rocks that didn't quite make the cut. That's why we have 2 types of planets. Rocky planets, Mercury, Venus, Earth and Mars. They are solid and the practical ones close to the sun. And then we have gas giants, Jupiter, Saturn, Uranus and Neptune, the massive gassy and slightly dramatic ones. Meanwhile, some unlucky space debris got stuck in asteroid purgatory, occasionally crashing into planets, like the big one that wiped out the dinosaurs. Thanks for that, space rock. And studying all these planets actually helps us to understand our own. By comparing Earth, Mars to Venus and beyond, we learn about its past, and maybe even where to find alien life. Come on, I know the little green dudes are out there. The Earth's crust is not just one big solid shell. No, it's more like a giant jigsaw puzzle, except the pieces are constantly moving and occasionally trying to kill us. These pieces are called tectonic plates, and they float on a hot, semi-molten layer called the asthenosphere. While for plates, there are 2 types. The oceanic plates, which are thin but super dense, like a weightlifter, or continental plates, thick but less dense, like a marshmallow. And they don't just sit there, they move. Thanks to possibly convection currents in the mantle, basically hot rock rising, cooling, and sinking, like a planetary lava lamp. However, new data shows that the convection currents might not have anything to do with it. Scientists are still puzzled and working on this, but it could be due to the dense gravity of the plates pulling them down, or any other idea. The Earth is still a mystery. All we do know is that they move, and this affects us all. All this movement means that they end up colliding with each other, and there are several different things that could happen. There are divergent boundaries, which is where the plates move apart. This is where new crust forms, like at the Mid-Atlantic Ridge, where Iceland is literally splitting in 2. There are also convergent boundaries, where plates smash together. Boom. Mountains, volcanoes, the Himalayas. These all exist because India decided to headbutt Asia. And then there are transform boundaries, where plates slide past each other. This leads to earthquakes. The San Andreas Fault in California is basically Earth's most unpredictable mood swing. Plate tectonics explains why continents drift apart, why earthquakes and volcanoes happen, and why some places have way too many natural disasters, while others just chill. Earthquakes are basically the result of tectonic plates playing a very high stakes game of stuck and release. Plates are always moving, but sometimes they get stuck. Stress builds, and when they finally snap free, boom, they release an earthquake. This happens on a gigantic scale, causing a massive shockwave to be released. Why do earthquakes happen? At convergent boundaries, where one plate shoves under another, this can cause huge earthquake events. When plates pull apart, they can cause smaller but frequent quakes. And at transform boundaries, where plates slide past one another, these cause violent and unexpected earthquakes, like a jump scare in your favourite horror movie. The shaking normally happens in 2 parts as well. The focus, which is underground, is a spot where the action all starts, and the epicenter, which is on the surface, is a place that really feels it the most. Scientists measure earthquakes with the moment magnitude scale because the older Richter scale wasn't cool enough anymore. And while we can't predict earthquakes, we can build structures to survive them. Shout out to the engineers. You could say a volcano is just Earth's way of relieving itself.
Just think you're a really cool island, and I'd like to get to know. Oh, God!
I have too much magma in me, and I need to let it out. Magma rises, erupts as lava, cools, and congratulations, you have new land. Volcanoes can happen anywhere. At convergent boundaries, one plate melts, magma rises, and boom, a volcano forms. A famous instance of this is the Pacific Ring, that massive ring going round the Pacific Ocean, full of volcanoes. At divergent boundaries, plates pull apart, magma leaks out, like in Iceland, forming vast amounts of land. You can also get hotspots. These are random magma plumes that don't care about plate boundaries. They cut through thin parts of the crust and also form islands, like Hawaii, which is constantly forming new islands, which is pretty cool when you think about it. As the plate moves, the magma plume carries on shooting lava out, which means one island stops forming and new islands start. Hawaii is basically an everlasting chain of islands forming in a line. And not all of these eruptions are the same. There are normally explosive eruptions which are violent, ash-filled and scary. Think of Mount St. Helens or even the terrifying Pompeii. And then there are also effusive eruptions, chill, slow lava, which flows down and looks kind of tasty for some reason, like in Hawaii. Volcanoes can destroy towns, but they also create new land, enrich soil, and even affect climate. And yes, scientists monitor them with seismometers, gas sensors, and satellites, because we'd really like to know before one blows up. That's it for global structures. Obviously there is a lot more to cover, but I just wanted to give a little brief overview of the topic, see if you find it interesting, and if you want to learn more. I'm sure I'm going to be covering more topics in the future, so keep an eye for them.